Now let me solve one more problem to find the Fourier series for any one function. Example: find the Fourier series of x squared in the limits from minus pi to plus pi. Here the function f of x equals to x squared. This is my formula for Fourier series. Step 1. To check whether the function is odd or even. First, to check that whether the function x squared is even function or odd function. The given function f of x equals to x squared. Let me multiply the variable x by minus, which equals to x squared. If you multiply the variable x by minus and then take its square, it equals to plus x squared, which is my given function. It is also plus x squared, and therefore x squared is an even function. Now I'm going to find the values for a sub naught, a sub n, and b sub n, which are the coefficients of Fourier series. Step 2. The value of a sub naught equals to 1 over 2 pi times integral of x squared dx, which equals to 1 over 2 pi into 2 times integral of x squared dx, with the limit from 0 to pi, because I have multiplied it by 2. The given function f of x equals to x squared, which is even function. Therefore I'm going to find the value of a sub naught. Remember, if the function is odd function, it automatically equals to 0. But if the function is even, you can calculate it further. So I'm going to take integration of x squared, which equals to x cubed over 3. When you expand the limits, at the end you will get pi squared over 3. This is my a sub naught. Now b sub n, which equals to 1 over pi times integral of x squared times sine nx dx, where my given function f of x equals to x squared, which is even function. But sine nx is odd function, so even times odd equals to odd. Therefore this whole thing is odd. Now let me take a sub n, which equals to 1 over pi times integral of x squared times cos nx dx, which equals to 1 over pi into 2 times integral of x squared times cos nx dx, with the limit from 0 to plus pi, because I multiplied it by 2. The given function f of x is x squared, which is even function. Cos nx is also even function, so even times even equals to even. It makes this whole thing even. Therefore I'm able to solve for a sub n. It is the product of two functions, x squared and cos nx. X squared is an algebraic function, cos nx is a trigonometric function. If you have the product of two functions, normally we use integration by parts technique. This is the common formula that we use for the integration by parts technique. But since I have one pure algebraic term here, which is x squared, therefore I'm going to use the other technique. Here is my differentiation, this is my integration. Put x squared under differentiation panel, cos nx under integration panel. Derivative of x squared is 2x. Integration of cos nx equals to sine nx or n. Derivative of 2x is 2 minus cos nx or n square. Derivative of 2 is 0. Integration of minus cos nx or n square equals to minus sine nx or n cube. I stop the process here because I got 0 at the left side for differentiation panel. It starts from minus and then plus, minus, plus. Take cross product here between the diagonal terms, which equals to x squared times sine nx or n plus 2x times cos nx or n squared minus 2 times sine nx or n cube. Expand the limits 0 and pi here, where these four terms equal to 0. If you remember, we have done this in prerequisite lecture. Sine n pi equals to 0 and sine n 0 is also 0. That's why I told you at that time that you must keep this thing in your mind, because we frequently use this in Fourier series. Cos n 0 equals to 1, but it is a product of 0, so this term is also 0. And I left only with 2 pi times cos n pi or n square, which equals to 4 over n square into cos n pi. Cos n pi equals to minus 1 to the n, which depends on the value of n. So this is my final value for a sub n, which equals to 4 over n square into minus 1 to the n. Now substitute all the values of a sub naught, a sub n, and b sub n in this formula. Just put them here. The values of e sub naught and e sub n are here, which are pi square over 3, and 4 over 9 square into minus 1 to the n. The value of b sub n is 0 here. Simplify the equation further to have pi square over 3 plus summation of 4 over n square into minus 1 to the n plus 1 times cos nx. Now I'm gonna substitute some random values for n. If I put the value of n equals to 1, it equals to plus 4 cos x. If I put the value of n equals to 2, this term equals to minus cos 2x. If I put the value of n equals to 3, this term gonna be plus 4 over 9 times cos 3x. If I put the value of n equals to 4, this last term will be minus 1 over 4 times cos 4x. And this is my final Fourier series for the function x squared, which is an even function, if it is defined in the limit from minus pi to plus pi.